Hello, welcome to this talk as part of the Trusting the Text Corpus-Assisted Approaches in Education Research seminar as part of the BERA conference. And this particular talk will be about structural topic modeling of Ofsted documents. My name is Christian Bokova. I'm an associate professor at the Southampton Education School. And I've been working with computational methods for some time. So in this talk, what I want to do is the following. I first want to introduce you to computational social science, where we try to utilize computer science methodologies to approach research questions that have scale, lots of documents, for example, that you would like to study. Then I want to say something about the Ofsted inspection context for those who are unfamiliar with this, but also what that means for the data that is produced by them, and also some prior research that I've already done previously. Then for this particular part, I've looked at some structural topic modeling of these Ofsted documents, and that should bring me then to some conclusions regarding both the use of computational social science and the actual context in this case, using these methods for Ofsted documents. All right, let me first start to explain what computational research methods are. And I rely on some sort of rigorous sources that try to define this. And we could look at it as an approach, these research methods that rely on forms of automated analysis of information using computers to answer education research questions. So it's the emphasis on automated analysis that actually will aid us in answering these questions. And these methods can include one or more of several things. They can be an analysis depending on algorithms, things like artificial intelligence, where computers make complex human-like judgments, machine learning, could come into play. Machine learning, which is basically a regression, but in a more sophisticated way. And data sets often are quite large. Some people will know the term big data, sometimes millions of sources, millions of documents, maybe millions of tweets, all kinds of sort of big data sets that you would want to analyze. And often these data actually already exist. They are not always collected specifically for research purposes. So, for example, they can be scraped from websites like blogs. PhD student I looked at, well, she finished now, looked at the blogosphere and what was being blogged. They can be extractions from databases like journal contents and abstracts, social networks, and they can even be simulated data. So we're talking about big data and also about sources that often already exist. And roughly speaking, if we look at Cioffi-Revilla's 2017 distinction, there are different forms of computational social science, each associated with certain computational research methods. For example, automated social information extraction, social networks and social complexity, or social simulation modeling. So there's simulation, there are social networks, but here in this particular talk, we're looking at the first category, automated social information extraction. And the context that I chose is a context I started with a couple of years ago already, in the education realm in the United Kingdom. Well, actually in England, we have Ofsted, and Ofsted is the inspection, and the inspection service always goes to schools and then judges these schools on certain criteria. These reports, and this is a screenshot from a website that's, I think, already changed a little bit, but these reports are available. Schools get these reports, but everyone can access them, and they give an overview of what is good and what could be improved in the schools. Here you see a fake school, the Computational Social Science College, and you can see the overall effectiveness and different criteria like the teaching, like the leadership. They're all part of these reports. And of course, there are other documents as well. There are different types of inspections, shorter inspections, long inspections. I'm not going to distinguish between them here at the moment, but you can imagine that these documents say something about the schools and the way that they have been inspected. And previously, I started analyzing these. And obviously, and you can already see this in this table on the left, there are a lot of documents, and there are a lot of each document has lots of pages. So here you can see the reports available from the year 2000. This is from a piece of research that I've done about 6 years ago, and you can see that there are loads of reports that are being produced, and all these reports, well, I would like to analyze them. But obviously, this then poses a challenge, because how can you analyze such a large corpus of data? Each of these reports is multiple pages. Every page has thousands of words, or every report has thousands of words. So it's very difficult to analyze them at scale. And this is where computational social science perhaps can come in. What I wanted to look at, for example, in this particular context, is whether reports, which would always culminate in a judgment inadequate, requiring improvement at the moment, because in the older longer ago, requiring improvement was called satisfactory, but they changed the judgment, or a judgment of good, or a judgment of outstanding, whether indeed the fact that a school was judged better or higher would be associated with a more positive sentiment. So sentiment analysis is a technique where you can actually look at the value of the words and whether the sentiment of the language in the text actually is more positive or more negative. And this was my first exploration of all of this. And I continue to work with this also with my colleague Sam Sims, and this then led to further findings. Here you can see a poster that we presented a while back, where sentiment analysis is able to denote policy changes in English secondary school inspection reports over time. So, for example, if you look at the time period that a certain inspector or head inspector was leading Ofsted, then the sentiments would be slightly different, higher or lower, depending on who it is, than maybe other lead inspectors at the time. This culminated in an article in the International Journal of Research Method and Education, where we demonstrated the potential of text mining for analyzing school inspection reports, where we did a sentiment analysis of 17,000 Ofsted documents. The idea, as said, was to take all these reports categorized on judgment, but also categorized on head inspector, which often is a political appointment as well, a head inspector, number of documents, and then applying these sentiment analysis scores. And what you could see is that, well, as we would expect, that inadequate reports had a far more negative sentiment than outstanding reports, and good was well, better than inadequate, but not as good, so good as outstanding. But what especially was quite interesting to see is that if you look at the satisfactory reports, and at the time there was this talk that, well, satisfactory is a bit too positive in a sense. It doesn't incentivize schools to really work on their improvement. And if indeed you would just base it on the sentiments of the reports that of schools that got the judgment satisfactory, then indeed they were actually almost as positive as the good schools or the good inspection reports. And after this was changed to requiring improvement, it actually went down in sentiment, perhaps not as far down as you might expect. But the whole point of this exercise was to show that indeed you could mine all these documents, these thousands of documents with millions of words, and you could actually discern certain policy changes over time. And something similar could be seen if you looked at these periods where certain head inspectors were in control. There were differences in the sentiments of these different head inspectors as well. So again, hard to interpret. And I will finish because in the latest analysis there also are lots of caveats and disclaimers, but the point is that manually you would not be able to go through all these documents. Well, you would be able, but it would take thousands and thousands and thousands of hours and days and weeks. So it's not really feasible. And by using computational social science methods, you can actually discern some patterns. And of course, with the appropriate caveats, that I think is quite interesting. So for this particular paper, I have utilized an R package called STM, Structural Topic Modeling, which comes from a paper by Roberts et al. Of 2019. And is a package in R. I don't know if you know R, but R is a statistical package, open source, and this package is open source as well. And in the paper, they explain what a typical process would look like. You would ingest the data, or import, if that's a word you like more. You would then prepare the data, which I'll say something about in a moment. And then you would use so-called structural topic models to actually see if perhaps there are certain patterns in and certain topics in the corpus that you've got. The corpus is the collection of documents that you are looking at. And you can then evaluate, understand, and visualize all of them. And I certainly have not done all these things, certainly not for this particular paper, but that is the workflow that I've been working with. As you might have seen from the screenshot previously, I worked with the same corpus as the article that I just mentioned. So that's 3,155 documents or reports classified by judgment. So we've got reports for outstanding, good, requiring improvement, satisfactory, and inadequate. What you typically do in a text mining exercise is that you process the data, you make sure that it becomes lowercase, so there is no distinction between lower and higher case. You do certain stemming, which means that if words have the same stem, then they are counted as similar words, so that you've got all the sort of verbs all together. Removing stop words, small words in the English language, removing punctuation, removing numbers, all of this together. And after that, there was still a corpus with, of course, 3,155 documents, but with 1,435 unique terms. And as you can see, 1,767,508 tokens. And the tokens are the, let's say, the individual items, individual words that were then considered. And what you can do in structural topic modeling is then include some covariates to see if there are some differences between the different documents based on those covariates. And I included judgment and age as covariates. All of this was done in R, so just a small impression of the R Studio package. You can see the code over here. You can see some of the stuff that I've been doing here. You see that I'm running some models here with topics, and you can see some components. This is not meant to sort of be a full introduction to R, but just to give you an impression of what such analyses would look like. So this is the code that you then would create. And now going to the findings. So these structural topic models, what they do is you need to indicate how many topics you want to extract. And then based on that number, it will try to find coherent topics, and then it can tabulate the words that are in those topics. If you are familiar with cluster analysis, you could almost see it as sort of looking for clusters of words that belong to those documents. This is a very simplistic way of describing it. So if you do know more, you're going to cringe, but I think that explains it quite nicely. And in the analysis, I extracted 10 topics at first, and later I ran some with 15 and 20 as well. It goes outside of the time for this presentation to really dive into each of these topics. I could spend 5 to 10 minutes to each of these topics, and there are at least 10 But just to show you what it looks like, for example, there was a topic where words like disadvantage and safeguarding and governors. So you could say, I would summarize this perhaps as pupils who were perhaps struggling and were a bit disadvantaged in this particular topic. Attendance, you can see, and their records, identification, short, maybe that they were in school for a short time. And here we basically already see a little bit of a challenge in these computational methods. It is very nice, of course, that millions of words can be summarized in these topics, but they are sometimes hard to interpret. What theme does the whole topic refer to? It's all computational. So this is where our judgment, our researchers' judgment, and also our knowledge of the context comes into play. And what you can then do is within the topic, you can create word clouds, but also you can create keywords in their context. So you can take these words and you can get certain quotes where these words together are being used. And these sections, these quotes from the reports will tell you more and more about your, how correct your interpretation is. And in this case, that was actually, I was quite convinced with these. But just to demonstrate that some topics are really difficult and maybe even noise and random, there was a topic, for example, where even individual letters were extracted, and these numbers, middle, center. So this is caused by the stemming that I talked about: performance, biology, community, maybe sixth form. This doesn't really make much sense, of course, and you really have to either dive deeper or you have to think about different number of topics to extract, etc., etc. So in that sense, it is not a straightforward process, but there certainly are quite a few topics, well, more topics do make sense than the number of topics that don't make sense. But I thought it was quite important to also show, the challenges involved. And what you can do is then also visualize topics like these in these types of diagrams where each circle is a topic and each topic consists of certain keywords. This is a screenshot actually from an older analysis, not the STM analysis that I showed, but I just wanted to show you how they can then be visualized. Am I the only one who's doing this? Not at all, just to show you that there is a very, a broad range of topics that you can actually approach with these methods. There are some very nice examples where Munoz, Nair, Galvez use text analysis to look at the paradigm wars in graduate research, so looking at keywords that belong to paradigms in research, and also a very nice analysis by Inglis and Foster, who looked at the social turn in 5 decades of mathematics education research. So how did constructivism, for example, develop over time? What can we conclude from this? Well, I think that it is completely unrealistic to analyze such large corpora of documents. So basically, if you've got thousands of documents, then you need some sort of way to analyze them at scale. So large corpora of documents can be analyzed at scale with these computational methods, sometimes maybe referred to as text mining or topic modeling. And there are several ways to do this. For example, I showed you sentiment analysis, but there also is topic modeling and structural topic modeling. Some methods allow for including other variables. So, for example, you could include the judgment, and this could, in the Ofsted reports, and this could tell us that perhaps certain topics arise more in certain judgments. So, for example, the whole theme of disadvantage does occur more often in inadequate and requiring improvement judgments. And that, of course, can be really interesting from a research perspective. Real-world documents, however, are very messy. So these were all scraped from the website, the Ofsted website, and they probably require quite a lot of cleaning. to be useful. You saw in one topic had one letter words. That's all part of the way that the text is being processed, and that can actually make it quite messy. And even if it's not messy, then interpretation can also be a challenge. Another thing I've mentioned is that the number of topics to choose is not straightforward. There are methods for this, something called perplexity, for example, but that, of course, adds to the work that you will have to do. However, it will never be as much work, of course, than doing all of this manually. But just to conclude, I don't think that computational methods on their own are the answer, but I think that they actually work really nicely in combination with qualitative methods. So, for example, when I set quotes in context, that is really quite qualitative. You know exactly where to go and where to look. But because of the large amount of documents that you would be analyzing, you do need something else there as well. And one way to actually do this is to employ these computational methods. Thank you. And if you have any questions, you've got my email address here. I'm on Twitter as well. And although I don't post a lot on my blog, bokhoven.net, the slides will be available there as well. Thank you very much.